The sheer presence of DNA that's claimed to be hundreds of thousands, if not millions of years old, argues against the hundreds of thousands to millions of years. DNA breaks down very quickly. It's attacked by oxygen, it's attacked by water, it can form knots and snap. Based on that, there's no way you're going to find DNA in something like a million-year-old animal, even in permafrost. There's another thing called genetic entropy. Natural selection is blind to most mutations, so they tend to build up over time. Species cannot be billions of years old, let alone millions of years old, or so many mutations would have built up that things would be extinct.
DNA barcoding.
Oh yeah.
What is that, and why do we care?
That's an interesting question.
DNA is a long and fragile molecule. It breaks down in the cell, and it breaks down in the dirt after an organism dies. Yet evolutionary biologists claim to have found DNA hundreds, thousands, or even millions of years old. But this contradicts the timeline given in the Bible. Can these two be reconciled? Dr. Carter, you have a PhD in coral reef ecology and genetics, and you've studied this topic quite a bit. And you actually chose the title of this episode, DNA Can't Be More Than 4,500 Years Old. Why that title?
It's actually a multifaceted title. It means multiple different things. There are a lot of things in science to show us that DNA cannot be millions of years old, and scripture says that DNA is only thousands of years old. So we're talking about DNA breakdown in the cell. How long can a species survive against the withering blast of mutations that all species are picking up? We're talking about DNA in the ground. How long can DNA last in a cave? Do we really have DNA from a woolly mammoth from 300, 400,000 years ago? Is that really true? We're talking about being able to date something called Y-chromosome Adam, the father of all of humanity today, and Mitochondrial Eve, the one mother who's the female ancestor of all humans alive today. How long ago did they live? Well, the science says not that long ago. There's another thing called DNA barcoding, which I'm sure we're going to get into. But just by looking at one particular gene that just mutates at just the right rate, you can separate species. I mean, a huge range of species of different types of organisms. The species seem to be the same age, as if some giant environmental effect happened at some fairly recent time in the past.
Okay.
And then we have the biblical date. So when we're talking about if there's dinosaur DNA, those dinosaurs must have died out in the flood.
Okay.
Woolly mammoth DNA has to be after the flood. Those are post-flood animals, and the flood was about 25 or 4,500 years ago.
Okay.
So that's where the number comes from. DNA can't be more than 4,500 years old.
Okay. That's a lot of topics.
A whole lot, yes.
Lots to unpack across a number of different fields there. Let's start with your first point.
Okay.
How do we know that all species have to be young based on mutation rates?
One of the primary axioms, in fact, Dr. John Sanford called the primary axiom in evolution, is that mutations happen, but then natural selection can remove those mutations. But he and I and others have shown very clearly, mathematically, computationally, and even in biology, that natural selection is blind to most mutations. So if you had a spelling error in a book, like a textbook, it's not going to cause you to fail your final exam. But if you had many millions of spelling errors, you couldn't possibly pass your final exam.
Yeah.
So any one mutation is almost irrelevant to an organism. Most mutations, some of them are deadly. Those get removed very quickly, but most of them don't do very much, but they're still mistakes. And natural selection cannot remove them. So they tend to build up over time.
Okay.
Which means as they're inexorably building up, species should be getting weaker and weaker and weaker. And eventually, there'll be so many mistakes that no species can possibly survive. It's called genetic entropy. And that tells us that species lifespans have a limit. Now, there's no hard limit, and it's going to be different for every different type of organism. But species cannot be billions of years old, let alone millions of years old, or so many mutations would have built up that things would be extinct.
Okay. Like they wouldn't be able to reproduce or even just function normally.
Yeah.
Before we continue, quick heads up, stick around until the end of the interview, because for a limited time, we'll be offering an exclusive free stream of Dr. Carter's popular presentation, Ancient DNA. It covers a lot of this info in even more depth. You won't want to miss it. Now back to the discussion. We often get told that mutations are the engine of evolution, right? That they're you have all these mutations and they build up and they change an organism from one to another. And isn't it true that there are some mutations that actually benefit an organism? I'm thinking of a polar bear with a broken melanin gene, or even fish in caves that gradually lose eyesight or even eyes. So isn't that an example of evolution?
Well, interestingly, the two examples that you picked are examples of something that's broken. It's a broken melanin gene that produces the white bear. It's the broken system for producing eyeballs that produces an eyeless fish. Another example is sickle cell anemia in Central Africa. A lot of people carry sickle cell anemia because that trait allows them to survive childhood malarial infections. So it means they're more likely to reach adulthood and have children. So yeah, natural selection is selecting for people that can survive to adulthood. Great. But it's a broken gene. In fact, it's a disease that's painful. But it's better to be sick than to be dead when you're talking about, reproducing and having children. So it's a kind of an extreme example, but those three examples are something that's broken. So yeah, natural selection can work on a few things, yeah.
So it basically, we see the mutation provides a benefit in a specific environmental context.
In contextualized benefit, but it's not benefit over the long term. So natural selection is always going to take the shortest, easiest route. If something occurs that allows the organism to survive, it's going, yeah, that thing's going to survive and it's going to multiply. But it doesn't mean it's multiplying because it has a good mutation. It's just something new. And a lot of new traits are broken things. We see that a lot. And that's most examples I know of things that are being naturally selected are actually broken genes.
Right. And then if that context is removed, like, for example, if malaria disappeared, sickle cell anemia, people who have that mutation would still be suffering the ill effects of sickle cell anemia. And now there's no way, if hypothetically everybody had it, there would be no way to remove it. And so it would represent a downward movement, not evolution.
Yes. So the appearance of mutations is not proof of evolution. Most often not, it goes in the wrong direction for evolution. But those are the extreme ones. What about all the more subtle mutations, the things that really don't have a profound effect on survival and reproduction, but it's still just a slight step down? Then the next one's a slight step down. And when you accumulate millions upon millions of those, you're genetically in trouble.
Got it. Okay, so that's the topic of genetic entropy in a nutshell. Obviously, there's a lot more that we could talk about.
We could do a whole hour session just on that. But
Let's talk about ancient DNA and how that relates to this topic.
The sheer presence of DNA that's claimed to be hundreds of thousands, if not millions of years old, argues against the hundreds of thousands to millions of years.
Okay.
DNA breaks down very quickly. It's attacked by oxygen. It's attacked by water. It can form knots and snap. It's attacked by all sorts of things. I mean, bacteria and fungi would eat DNA. And so when you find a bone in the dirt, well, there's bacteria and fungi living in that bone.
Yeah.
And it's been rained on. And oxygen's probably there. If not, it's still water present. Ice crystals destroy DNA. And so we find the oldest supposed organism with DNA that's intact is found in the polar regions, in cold areas. We don't really find much in Africa where it's hot.
Okay. And that's because cold preserves DNA.
Because cold preserves it, but only to a limit. It doesn't last forever. Now, you can probably ask me next, well, how long does it last?
Yeah.
I anticipate that, right? Is that what you're going to say? We don't necessarily know. We can measure in the short term. So the oldest DNA that's claimed to be found is over 1 million years old. They pull it out of an organism, sequence them. It's only little pieces. They're not sequencing entire genomes, but they're able to pull out pieces of DNA, sequence them, say, okay, this is what the woolly mammoth or the ancient horse or the cave bear, this is their DNA, and this is what their genome might have been like. But we don't know how old that stuff really is. And based on DNA decay rates, there shouldn't be any DNA there. So you're probably wondering, how do we measure the DNA decay rate? Well, we actually can't. We can measure over the short term in the laboratory, but how do you extrapolate that to hundreds of thousands of years? So the one study that I know of that tried to do this, they used ancient moa bones from New Zealand.
Yeah.
They carbon dated the moa bones.
Big bird, right?
Yeah, giant bird. They carbon dated the bones, and then they measured all the pieces of DNA that were in the bones and how long they were. And they had a decay curve of how fast DNA breaks down over time. Okay. Based on that, there's no way you're going to find DNA in something like a 1,000,000-year-old animal, even in permafrost.
Okay.
You definitely never find it in like a dinosaur.
Okay.
Because they supposedly died out 65 million years ago. There's no way there's DNA there, but there's biochemical evidence of DNA. There's microscopic evidence of DNA in dinosaurs. We don't have sequence data yet because the pieces, I mean, that stuff, if the dinosaurs died in Noah's flood, that's 4,500 years old. That's really, really, really old for DNA. It should be almost all broken down, but there's some left in some cases. I know of at least 2 groups that are chasing dinosaur DNA. Someone's going to do it eventually. It's just difficult because when you pull a dinosaur bone out of the dirt, it's full of modern bacteria and modern fungi. And the amount of DNA from those organisms way overwhelms the little bit of trace amounts of ancient DNA that might be present.
So are you saying that we could get Jurassic Park soon? Because I would like to go to that.
Man, I would too, but no, we're not. It's not going to happen.
Okay.
There is a team in Japan that's working on cloning the woolly mammoth. And they've got millions of dollars and they're working on it and they're making some progress, but they're not actually going to clone the mammoth because the mammoth genome is broken down. It's in pieces. You can't just take the DNA out of a mammoth cell and stick it into an elephant egg cell, say, and make it a mammoth. So what they're going to do is they know the genome of the mammoths. Okay, that's the gene for the hairiness. That's the one that makes the big tusks. This gene might affect the funny shape of their head. And they're going to genetically engineer an elephant with those traits and then try to put that egg into a female elephant and have her give birth to what looks like a woolly mammoth.
Got it.
But you can't do that with dinosaurs. See, woolly mammoth is an elephant. So you can change the elephant DNA to make it look more like a woolly mammoth. What's like a dinosaur? Nothing.
Yeah.
There's no comparable species that you can manipulate to resurrect a dinosaur. So it's not actually going to happen. But someday we're going to have dinosaur DNA. It's just a technical question of who's going to do it first and what's the best specimen to use. It's going to happen. But that dinosaur DNA will contradict the age of the bones.
Okay.
Now, I said a minute ago that they use carbon dating to date the Moa bones.
That's right, yeah. And I know that we have a lot of materials here at CMI about carbon dating.
A lot of things. In fact, in my article, How Carbon Dating Works on creation.com, I have a chart of how as you go further back in time, the carbon dates start leaving the historical dates. The carbon dates are older than the historical dates. And I suspect that the closer to the flood you get, the more they diverge from reality.
And we're talking about historical dates of things
artifacts.
Artifacts that we can pretty reliably verify.
Yeah, the destruction layer at Jericho or a pharaoh's sarcophagus. In fact, the Willard Libby, who invented carbon dating, he validated his technique on Egyptian coffins. And he said, it's the strangest thing. The oldest coffins that I'm using diverge more from the expected date than the younger ones.
Okay.
And there's more. I really think that the closer to the flood you get, you're going to get an escalation of the carbon dates because, well, there's some carbon-14 in dinosaur bones, a little bit.
Yeah.
Well, that's telling us that there's a little bit of carbon-14 before the flood. There's a lot more now because as the Earth's magnetic field collapses, as we see, as all sorts of other reasons for expecting carbon-14 to change over time. Creation.com is a great resource, everybody. When you look at an ancient Moa bone, it has less carbon-14 than it should based on its age.
Okay.
So it has an apparent older age than its true historical age.
Right.
So not only, if you just take the evolutionary estimates, DNA breaks down too fast to get a 1,000,000-year-old sample with any DNA. We know that now. Okay, great. But if you put the biblical constraints on it and you crunch down those carbon dates, it's even worse. Because the true breakdown rate is much, much, much faster than they want to acknowledge. So in our model, hey, we're going to find some DNA of a dinosaur. Great. That fits the biblical time frame.
Yeah.
But barely. It's really hard to get it. But if they find dinosaur DNA and they claim it's, 70 million years old or so, no, it's not.
It doesn't work at all.
Yeah. So ancient DNA puts a limit on how old the Earth can be.
Got it.
And it's a biblical limit. Thousands of years, fine. Millions of years, you got a problem.
Okay. So that's going over the breakdown of DNA once it's actually in the dirt.
Yep.
Let's shift gears again because we
Okay.
have a lot of topics to cover
A lot
here.
of topics, yes.
You mentioned Mitochondrial Eve.
Yeah.
Tell us what that's all about.
In the Bible, there is a single woman who's the ancestor of all people who've ever lived.
Mm-hmm.
Her name is Eve. There's also a single man who's the ancestor of all people who've ever lived. His name is Adam. In the evolutionary world, they realized in the 80s that all people in the world can be traced back to one woman. They just called her Mitochondrial Eve, almost tongue-in-cheek. Now, they don't believe she's the biblical Eve. They don't even believe she's the only woman who was alive at the time when she was alive.
Yeah.
But she was in a population, a small population, just through dumb luck. Her mitochondria actually is the only mitochondria found today. Because, some women don't have any daughters. Mitochondria is only passed through a female line. If the woman has only sons, her mitochondrial line's extinct.
Okay.
Same is true for men. We pass on Y chromosomes, but if a man doesn't have any sons, his Y chromosome is extinct.
Yeah.
So given enough time, there will be enough extinction of enough lineages that only one will remain.
And this is the evolutionary model of where humanity came from.
The evolutionary model. It only works in small populations.
Okay.
Like my Y chromosome is never going to spread out and replace all the Y chromosomes in the world so that all the people in the future are going to be a Carter.
Mm-hmm.
It's never going to happen. Mathematically, it's impossible. But in a small population, it happens in a couple of generations. In fact, the rate of it happening is inversely proportional to the population size.
So if you have a small population, it happens a lot faster.
Yes. And it slows down quickly as this population size grows. So they say, well, we must have come out of a population with an effective size of about 10,000 individuals.
Mm-hmm.
Now, 10,000 is a lot of people. It would take a long time for this mitochondrial Eve to replace all the other Eves that are there.
Yeah.
And so they never tell us that, but it's a long population bottleneck that runs for many, many, many thousands of years.
Mm-hmm.
And Eve will naturally arise. And an Adam will naturally arise. But the evolutionists call this Adam Y-chromosome Adam. Again, tongue-in-cheek. They don't believe it's the Adam. But that actually shows a little bit of biblical ignorance. Because our Y-chromosome ancestor is not Adam.
Mm-hmm.
It's Noah. Whatever happened between Adam and Noah, we'll never know. We don't have Adam's Y chromosome. We don't have any of his descendants' Y chromosomes except for Noah.
Yeah.
And if any mutations occurred along the way, they're invisible to us. We can only go back to Noah.
Because there was a big population bottleneck that happened around 4,500 years ago.
At the flood, we had Noah and his 3 sons who all inherited Noah's Y chromosome. Now, it is possible that Noah's 3 sons married their sisters. I know it's disgusting to think about, but it's possible. In which case, Noah's wife is Mitochondrial Eve, not the biblical Eve.
Okay.
But if the 3 daughters-in-law of Noah aren't sisters, then the common ancestor goes back before the flood and might go all the way back to Eve.
Got it. I see what you're saying. Well, talking a bit about that population bottleneck there, I know you said that they assume that there is an effective population of about 10,000 individuals, and that continues for a while. But aren't there also some models that suggest that humans had an even smaller population, like maybe 1,000 individuals?
There's a new paper that came out a couple of months ago that was claiming that 1 million years ago, the human population is reduced to like 1,200 people or fewer for 100,000 years.
Okay.
That's a long time for a small population, and that's almost guaranteed extinction.
Yeah.
I mean, population geneticists across the world, wildlife ecologists across the world are worried about the cheetah. There's about 10,000 of them in the wild, but they're broken up into little pockets. Like there's cheetahs in India, there's cheetahs in Africa. But the cheetahs in Africa are in isolated pockets, so they're smaller than 10,000. That's too small of a population for a large vertebrate animal with long generation times and only a few offspring.
Okay.
That means that they have to inbreed too much. So everyone's worried that cheetahs are going to go extinct. Well, how did we survive? How did early humans survive a 100,000-year population bottleneck with just a little over 1,000 people?
Yeah.
That's really bad.
Yeah.
For instance, today, you don't marry your cousin. Why not?
Well, the mutations are going to stack up really, really quickly.
Yeah, they
There's
stack
no
up.
copies.
There's a high probability that you and your cousin have the same mutation. And if you pass that mutation to your child, they get a double dose of the mutation. So cousin marriages, in the U.S. at least, are not supposed to be legal. because genetically it's not safe.
Right. And that's what we're seeing with the cheetah populations
Yes.
that are so small. Basically, they're not going to be able to sustain themselves for much longer.
Yeah, but the reason why they invoked this long, very narrow bottleneck a million years ago is because they're trying to explain the lack of diversity in the human genome. People are surprisingly closely related. We're surprisingly similar to one another, especially considering there's 8 billion of us. But the reason is not much genetic diversity is because they only came from 2 people,
Yeah.
Adam and Eve. That's the amount of genetic diversity God put into Adam and Eve. That's what we see in the human population today. It's the evolutionists who are struggling to account for the lack of diversity. Actually, it's another thing that fits in with the biblical model.
Yeah. Well, and the issue is then you have 1,000 individuals, and then that population has to stay stable for 100,000 years. So let's assume they don't die off.
Yeah, no diseases, no big war or anything like that. Yeah, that's hard.
Well, and then why doesn't that population then expand rapidly like we see when a population does that in the wild?
Yeah, great question. And no one knows the answers to that. They're just modeling it. And the computer model says, if you do that, now you can explain how humans look today.
Got it. So it's almost like working backwards from the problem when the answer could be right in front of them.
Yeah.
Got it. So talking about bottlenecks, there's
Yes.
there's that bottleneck there.
Yeah, we got the million-year-old bottleneck. We got the out of Africa bottleneck a couple 100,000 years ago, or pre-out of Africa bottleneck. And
Then we have the biblical bottleneck of the flood, which we touched on a little bit.
Yeah.
So that's where we see the human population reduced very dramatically down to 8 people who survive on the ark. And from that, we believe that we get all the people living in the world today.
yeah, but wouldn't that bottleneck have killed us?
That's
If bottlenecks are bad, wouldn't have killed us? The answer is no.
Okay.
Because a bottleneck, by definition, lasts a very long time. If you have a sudden restriction in the population size and they grow again, it's a totally different scenario. In fact, you can't even know if in human history how many of these very narrow bottleneck events we had if they only lasted 1 or 2 generations. You do lose some diversity. In fact, the calculations I made in some article I published on creation.com, it depends on how close related Noah and his wife are and how close related the daughters-in-law are to the sons. But you're going to lose about 20 to 40, not quite 50% of all the genetic diversity before the flood because of the flood scenario. So most of the DNA variations that God put into Adam and Eve are carried on the ark and are with us today because the population grew rapidly afterwards. I mean, Noah's got, 16 grandsons in Genesis?
And that's
10,
what
11?
we see coming right after, like we get the Babel account where there's a very large population of people who are all together and then God divides them by confusing their languages. But that lines up with rapid population growth after the flood.
Now, we don't know how large the population was at Babel. We don't know that. But it's 1,000, 10,000, somewhere in this region, and it's broken again at the small populations that then start growing themselves. But see, when you have a small population, you do lose genetic diversity. And that Babel event, that gives rise to the so-called races.
Yeah.
Because as some people go north or south or east or west, are only carrying some of the genetic diversity of the total population. And as they're marrying within themselves only, they lose more genetic diversity. And so if dark skin color genes are in one population, they might not be in the other population, et cetera, et cetera, et cetera. That's how you get species. That's how you get races, if you want to call them that.
Yeah.
It's through the loss of diversity.
I'm going to ask a question that's probably at the forefront of everybody's mind. You kind of alluded to the idea that maybe Noah's daughters-in-law were actually all sisters. And even if that wasn't the case, even if they were bringing in genetic material from outside of the population of Noah's bloodline, wouldn't there be problems with inbreeding if you have the population growing that quickly from that small of a group of people?
Yes and no.
Okay.
When you've got enough people, 8 people, then all of a sudden you've got 32 grandchildren. That's a lot. And then who knows how many great-grandchildren you might have. That a population is rebounding quickly and growing quickly, you don't get the inbreeding problems you have when you're a stagnant population.
Okay.
I could explain it mathematically, but this is something population geneticists know. You want to see populations growing, and then you escape almost all the problems you had if that population remains small.
Okay.
So a biblical bottleneck is not bad. It's the evolutionary bottlenecks that are disastrous.
So with regard to those mutations then,
Yeah.
even if there were maybe multiple copies of genes that can account for these mutations, is there anything about mutation rates or the potential, I think you called it a mutation load, that they would have been carrying that might have been different?
Okay, mutation rate is how fast mutations occur. Mutation load is how many mutations are in the population.
Okay.
There would have been 0 mutation load in Eden.
Right.
God created Adam and Eve with genetic diversity, great, but those aren't mutations. Those are God-created variations that are good. The problematic mutations will start building up over time. So right after the flood, another reason why the flood bottleneck wasn't bad is the mutation load was very low.
Okay.
It's only 10 male generations from Adam to Noah. That's not a lot of generations. And they're living a long time. I suspect the mutation load was really low. Mutation rate could have been high, but the total count would have been still low.
Okay.
But that also means that if you look at the amount of genetic diversity we have in the world today, and you look at how many mutations happen every generation, it's about 100 per person per generation.
Okay. That's a lot.
If you go backwards in time, it wouldn't take very long to explain all the genetic diversity we have amongst all the people in the world. So the mutation load of our population can easily be explained in a younger scenario.
Got
You
it.
don't need millions of years to accumulate the few differences that we have.
So the mutation rate that we see in the population potentially points us to the biblical time frame, right?
Yes, the numbers are on our side of the equation.
Got it. Hope you're enjoying the interview so far. We'll jump back in shortly, but real quick, imagine bringing this life-changing message to your church or community. This is exactly what we do. We host almost 1,000 events each year, and our experienced and accredited speakers come to you without charging a set speaking fee. They deliver engaging, illustrated, and impactful presentations covering a range of topics dealing with the creation and evolution debate. We've received thousands of testimonies from people who have had their lives changed through CMI's speaking ministry. If you'd like that for your congregation or community, then use the link in the description and contact us today. Well, going to play devil's advocate here.
Okay.
We were talking about how carbon-14 decay rates seem to actually be different the further back we go. That is, that there's a greater spread between the actual historical date and then the date that carbon-14 gives us.
Yes.
Could we not argue maybe, though, that the mutation rate might have been different?
Yes, we can argue the mutation rate might have been different. I suspect the mutation rate today is higher than it was in the past. Because if God created Adam and Eve perfect, with no defects, that means their cellular reproduction systems are also perfect with no defects. That means their DNA repair systems are perfect with no defects. The DNA repair in our cells takes a lot of effort. There's a couple of hundred genes involved in DNA repair. There's like 50 different DNA repair pathways for different types of things. Single strand breaks, double strand breaks, cytosine deamination, you name it. There's a different way to fix all the different things that happen to DNA. But if a mutation happens in one of those systems, it's going to hiccup more, and you're going to pick up more of that type of mutation. In fact, there's a famous thing that Lenski did with it's called the long-term evolution experiment. He took E. coli and put them in a flask without sugar and grew for many, 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 many generations. And a couple of them went extinct. A couple of those flasks out of that, I think it was 10 or 12, went to hypermutation.
Okay.
They picked up many, 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 many more mutations than the others. In fact, the different flasks picked up different types of mutations because one of their DNA repair systems was deactivated or broken. And they went haywire. Well, that can happen in humans too. There are people that we know that have defective DNA repair systems.
Yeah.
And it's more in that family line, more mutations per generation.
Got it.
There's also some people that are living in radiation hotspots. One particular place in India that I know, that the people living in this area have a much higher mutation rate than the people living around them outside of the radiation area. They're living on a lava flow that has a lot of radioactive elements in it. And so there's lots of ionizing radiation in the air in which they live. So you can have differential mutation rates. You can have an increase in mutation rate, which I fully suspect is happening. As the world winds down, as genetic entropy gets applied and mutations build up, I suspect that we're going to be having more and more and more problems in the future, more so than we did even in the past.
Got it. Well, and you mentioning lava flows carrying radioactive material and causing ionizing radiation. The first place my mind goes is the tectonic activity during the flood, when the fountains of the deep open up. Could that have been a problem if there's like volcanic ash being shot up into the atmosphere or something like that?
Yeah, you can have a lot more radiation exposure. Consider also that the Earth's magnetic field has apparently flipped multiple times in our history.
Yeah.
Well, that has to happen during the flood year. And if you collapse the Earth's magnetic field and invert it, during that collapsing time period, we're getting irradiated from cosmic rays from outer space.
Mm-hmm.
The Earth's magnetic field protects us from outer space.
Yeah.
Collapse that field, you're irradiating Noah and his family on the ark. You're irradiating all the things that are alive. So they might have gotten a whopping dose of mutations during the flood.
Okay.
Which might explain the rapid drop-off in lifespans after the flood, or at least contributed to it.
Okay.
So all sorts of things like that are possible. But all this can be accounted for in the young Earth scenario.
Yeah.
The amount of mutations we have, the time it would take to build up these mutations, the fact that we're still alive, it's all telling us that DNA is not millions of years old.
Got it. And so basically, that was a lot just for that mini conversation there.
Yeah.
But the takeaway there is that we can see from mitochondrial DNA and Y chromosomes that everybody on Earth is descended from one man and everybody on Earth is descended from one woman.
Yes.
Is that right?
That is true. And when we measure the mutation rate in families, like two cousins, second cousins, third cousins, if you count up the number of generations these people have been separated, count up the number of differences they have in their mitochondria. So the number of differences divided by generation time, number of generations, gives you the number of mutations per generation.
Yeah.
It's about one mutation every other generation.
Okay.
And the Y chromosome is about one mutation every 3, maybe 5 generations. Well, if you look at all the people in the world in mitochondria, the most extreme people are about 100 letters different. That would be 200 generations. That's 6,000 years. When you look at the Y chromosome, it's very complicated, but the areas that we sequence, the 10 million letters we routinely sequence, not all the repetitive stuff that's really hard to sequence, and look at the number of differences. There's a couple of hundred differences amongst men. Again, this is in the biblical time frame.
Okay.
We could even relax the mutation rate, and Adam and Eve are still going to be in the biblical time frame. So the dating of Adam and Eve, when you apply real-world mutation rates, they're not 200, 300,000 years ago. They're 5,000 or 6,000 years ago, right where the Bible would place them.
Right. Well, don't evolutionary biologists place mitochondrial Eve somewhere around 200,000 years ago in Africa and mitochondrial Adam somewhere else?
For a long time they did. For a very long time. Oh, Adam and Eve never even knew each other, you silly creationists. Ha, 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 ha. They lived at totally different time frames. But Ancestry.com got sent a sample from an African-American man. And when they did their panel on his Y chromosome, they said, "What is this?" And they called him up and said, "Sir, can we sequence your Y chromosome?" And they found a brand new branch. His ancestors were from Cameroon. He was an enslaved African. His ancestors from Cameroon. And it was a deep, deep, deep evolutionary root of the Y chromosome tree. That caused a doubling of the age for Y chromosome Adam. That one sample.
Yeah.
They doubled it, and now even the evolutionists are saying that Y chromosome Adam, mitochondrial Eve are in the same ballpark.
In terms of time?
In terms of time.
Okay.
So it's really funny how one sample can change everything. It tells you that their concept is based on a bunch of assumptions. Well, for us, the Bible demands an Adam, and the Bible demands an Eve. Evolution doesn't.
Got it, yeah.
They don't have to have this bottleneck. They don't have to have an Eve. We could have Y chromosomes shared with chimpanzees and mitochondria shared with gorillas. That's all possible in the evolutionary model, but it's not true.
Yeah.
It actually fits the biblical demands. There is an Adam, there is an Eve. How to date the Adam and Eve, the evolutionists say one thing, and I just like appealing to genealogical studies.
Yeah.
Because you know how many mutations separate these people. You know how many generations separate the people. And when you do that, Adam and Eve are recent.
Got it. Well, let's switch gears again
Okay.
and talk about DNA barcoding.
Oh, yeah.
What is that and why do we care?
I've been hearing about DNA barcoding for decades. When first I heard about it, that's silly. There's no barcode in DNA. Not like you buy milk at the grocery store and you go beep on the scanner, that little barcode. But there is a gene on the mitochondria that is highly constrained. You can't change it a lot without killing an organism, but it can withstand some mutations. So it's in kind of a sweet spot. It doesn't mutate a lot, so you can't tell the difference between like me and you, but it does mutate fast enough so you can tell the difference between chimpanzees and bonobos, between a dog and maybe a wolf and a coyote. Well, if you look at that particular gene, there's a certain amount of difference between them. But the strangest thing happened after they sequenced a lot of these across the animal world. They said, wow, all these species are about the same age.
Now that shouldn't happen.
That should not have happened. If you have a evolutionary tree of species budding off at all different times, you should have some species close and some species far away.
Yeah.
But what they found was all of these different species of all these different types of organisms are about the same age. So something ecologically must have happened. They say, about 10,000 years ago was their age that caused the rise of all these species simultaneously.
And that's why they have different mass extinction events to account for
What
that.
mass extinction event happened 10,000 years ago? The end of the Ice Age caused the formation of a whole bunch of species? In the evolutionary model.
Yeah.
That shouldn't happen. What this is it's a signal of Noah's flood.
Mm-hmm.
This is when the bird population is spreading out from the ark, and the things that led to cardinals went one way, and the things that led to blue jays went another way, and their gene in the mitochondria started mutating, and they're about the same age.
Yeah.
So elephants, bears, it's all these weird organisms have nothing to do with one another, and the species have about the same age because something happened in the past, and what happened was Noah's flood.
Okay. And we call it DNA barcoding because it provides almost like a barcode identifier for an individual species.
Yeah, it's a unique identifier. It's not a barcode.
Yeah.
I've always wanted to have them, show the sequence barcode-like,
Yeah.
just for fun, but they don't. It's actually ACGCTTACCCG, just like regular old DNA.
Okay. So we just covered a lot of ground. We went over DNA degradation in the cell. We talked about DNA degradation once it's in the dirt. We talked about Y-chromosome Adam, Mitochondrial Eve, and then we talked about DNA barcoding and how all of this points to a much younger age of DNA, both in terms of lineage and in terms of actual age.
Yes.
So why 4,500 years?
That's the kicker, isn't it? None of those things we've talked about so far give us an absolute date because science doesn't give you a date. It gives you approximations.
Right.
All of them are pointing toward a younger age for DNA than in the evolutionary model. The date comes from the biblical account. Now, there's a lot of ways to try to approach chronology in Scripture. Henry Morris and John Whitcomb, in their famous book, The Genesis Flood, it was 1961, I think it was written. Those two men almost single-handedly kicked off the modern creation movement. And Genesis Flood is a monumental work. In their book, they said the Earth's about 10,000 years old. Mm-hmm. I don't think it's that old. But they said that, okay, if it's 10,000 years old, I'd be perfectly happy with that. But they appealed to missing generations in the genealogies.
Right.
But I'm also a genealogy geek. And I've written a lot of articles about biblical genealogy.
Oh, yeah.
I don't see any evidence of gaps. No missing generations. The places where people appeal to missing generations, there's a very good reason why that name's not there. And it's really only in the Gospel of Matthew.
Okay.
And there's 4 missing kings. That's it. Other places, creation.com, type in missing generations, you're going to come up with some articles on these subjects. But if you make some assumptions about like how long the Israelites were in Egypt, how old Abraham was when how old Terah was when Abraham was born, which you can't really know, and you put all the dates that were given in the Bible together, you get a date range of a little more than 6,000 years, maybe 6,300 years, because there's still some ambiguities in there. But you don't get 10,000. You certainly don't get 100,000.
Yeah.
But the flood then was about 4,500 years ago.
And that aligns with the evidence that we've been talking about from genetics.
Yeah, all the evidence we've been talking about aligns with a biblical date. It's not proof of the biblical date. It just aligns with it. It supports the idea that the Earth is not millions of years old. The 4,500-ish years is just ish.
Yeah.
Because it's history. History is not perfect, and science isn't perfect, and science never gives you an absolute date of anything.
Yeah.
In history, it's really hard to find absolute dates in history. You consider different Bible versions, Septuagint versus Masoretic, you're going to get slightly different numbers, but that's all academic stuff for someone else to work out. We've written about that on creation.com also. But the date, 4,500 years, that's when the dinosaurs died out in the flood. That's how old their DNA is. That's why it's so degraded.
Yeah. Well, and the thing I'm thinking about too is a lot of people want to appeal to missing generations in the Bible. And I do get it because it lets you stretch out the biblical time scale and makes it feel like it's going to fit a little better.
The more stretched out it is, the easier it is for us to add history into it.
Yeah.
It's more comfortable. But the Bible really does hint that it's much less old than a lot of even Christians want it to be.
Right. But the problem is, even if we allow for all of it and say, okay, you can have, a 10,000 or even 100,000-year-old Earth, it still doesn't align with the evolutionary time frame.
That's right.
So there's a conflict.
No matter how much
there.
you compromise on the biblical age of the Earth, it's either billions of years old or it's thousands of years old. Why go to a middle position that makes no sense for either side?
But then, when we're talking about all of this evidence is pointing towards only a few thousand years. Yeah. Something has to give, and it seems to me like it's evolutionary biology, as traditionally understood, that's going to have to give way.
Yeah. DNA is one of our greatest weapons that we have, one of our greatest supports for the biblical idea. Multiple different areas it points towards the biblical account of history.
Dr. Carter, I know you talk about a lot of this stuff in Ancient DNA.
Oh, yeah.
And for our watching audience, we do have a special offer for a limited time. Your DVD, Ancient DNA, is going to be free to stream. Tell us about that.
As a geneticist, I want to know how to handle this brand new field of ancient DNA. And a lot of people are very confused about it, but there's so many amazing things. There's a dark time in human history between the flood and the establishment of civilizations. There's sometimes 1,000 years or more where nothing was ever written down. We actually don't know what happened there. We have, a campfire. We might have a mud brick house or, a small scale city or something like that. But they didn't leave writing. So we can only infer who came from where and who's related to whom and things like that. Well, now that we're able to pull DNA out of the ground, out of ancient bones, we can now tell the story of that missing time period. And it is absolutely fascinating.
Wow.
We can see people migrating across the world. We can see, Neanderthals coming into the fold, and Neanderthals are now Homo sapiens. I mean, you and I carry Neanderthal DNA.
Yeah.
In fact, you and I carry 2 to 3% Neanderthal DNA.
Oh, okay.
Which doesn't sound like a lot until you realize that means that for every one of your ancestors, every 100 ancestors you have, 2 or 3 of them were a Neanderthal.
Huh.
Oh, that makes us them and them us. It's like the Neanderthal population just kind of blended into the later migrants who moved up into Eurasia. They were the first people that got up into Eurasia after the flood. Okay. And later on, other people moved in and they mingled, which is why we carry their DNA. We didn't know that 20 years ago. We had no idea when the first Neanderthal DNA was starting to be sequenced. Oh, these things aren't human, haha. Well, that's not true anymore because now we got better and more sequences and they're clearly human.
Wow.
We didn't know that. So I'm explaining this to the audience. This is one of my favorite things I've ever done because I love history, love genetics, love genealogy, and I love the Bible. And put all those things together and we have this presentation called Ancient DNA.
And remember, for a limited time, we are going to make Ancient DNA free to stream. Link in the description below. Dr. Carter, thank you so much for your time.
Oh, Sheridan, I'm afraid we've only scratched the surface. Every one of these things we talked about, there's so much more to talk about. I love this conversation. I hope people watch this and I hope people go to creation.com to learn so much more.